Good morning, guys. Let's make sure we're live. We have got coffee brewing. Let's see. Looks like we're good. Coffee brewing over there. You can see it. There's some guys out there building a skyscraper, and we are going to be inside building something of our own. So thanks for watching. For those of you that are returning, great, welcome back. For those of you who just got here, we're a programming channel. We work on projects, we build them live, and we deploy them. We're doing real work. The idea is to work at a pro speed so that you guys can see exactly how a professional programmer works. And I talk out loud basically so that we can work through things together. Yeah, what we built so far with this video series is a budget management application. Really simple. We built it using a couple technologies, React, which is a big popular front-end framework with JavaScript nowadays, and Symfony, which is my favorite full-featured web framework, and that's with PHP, obviously. So I'm gonna go grab a coffee real quick. And this is bulletproof coffee, if you guys are familiar. But we're gonna dive in right now. So here we go. Today's lesson is all about deploying the application. Now, I tried to do this live, and live didn't quite work out as anticipated. It probably ended up taking about 5 hours to get all this together. Mainly due to PHP being so difficult to deploy and maintain. Once you get the deploy pipeline down, it's a lot easier, and I'll show you guys how we can do that with just a couple console commands now. It's a lot better, but it definitely it was frustrating, and I wouldn't even want my mom to have to watch that video of me pulling my hair out and cursing. So we deleted those videos and started this new one to just explain and give an overview of how we ended up doing it. And then that way later today we can actually get back to building more features. So yeah, so welcome back, and hello newcomers. This is the app we've been building. We've got two projects. Like I said, the API project here built in Symfony. We've got the React project built with React, obviously, and we want to be able to deploy it now. So with AWS, there's a couple ways you can deploy things, deploy APIs. There's actually a few ways. I chose to use this video to demonstrate using Amazon ECS, which is a Docker Container Manager, and it's really great because once you create an application and package it in Docker, if you give it to a container manager that works, it should keep your Docker containers running without any external intervention. So as long as the container works when it's deployed and built, it's going to continue to work, and you don't have to worry about things as much. Honestly, I think it's the best way to deploy an API so far. I know stateless is kind of gaining some traction these days, but I still think Docker with a good container manager is the best. So let's go over how we could do that and how we did end up doing that right now. And so to do that, we can just step through building it all from scratch because now I've got the steps down. So this application, our Symfony application, if we were to run it locally, what we would do and I think it's already running, so stop it real quick. But to start the web server so that we could see, let's see, to start the web server, we would run this command right here. And if we punch this into our web browser here, we can see we've got a Symfony application running. And we use it for API calls like this, because this is an API. We're not really going with an HTML front end. We don't have any desire to run our front end and actually serve that with the Symfony app, because we have our own front end that's going to be you know, a single page type deal, nice and responsive for our users. So this is how we would run our application on our local host for development purposes. Now, since this is running on our local host, we're unable for our users eventually to access this API from their web browsers when they're using a site. So we need to put this into a server online so that it's accessible. And how we do that is we use a web hosting service like Amazon Web Services. Now this is the AWS user interface if you've never seen it. It's pretty easy to register. You pretty much just sign up, give them your name, phone number, and credit card information, firstborn also, and then you're good to go. So to get started, we are going to deploy it to the EC2 Container Service. EC2 Container Service is the Docker container manager that I was referring to a second ago. So we can go in here. We can see I've already made one for testing purposes. Finally, it only took 5 hours. But we're going to create a brand new cluster so that we can see what it takes to set up a deployment of a Symfony application with ECS. So let's go ahead, and we are going to create a cluster. And a cluster is a group of servers that will maintain Docker containers for you. So you tell a cluster that you want a specific service running. So for us, we want our Symfony, our API, the budget API running on this cluster, and we want it to run one instance at all times and to just keep that running forever, basically. So we can call our cluster My Money Manager. The name is just an arbitrary name that we give. We want it to be descriptive so that we can remember when we've got 100 web apps running, we want to be able to go back and easily find where our My Money Manager cluster is, so we call it My Money Manager. These default settings are just fine. For us, we don't need a big EC2 instance. This M4 large instance would cost us about $150 a month, I think, in the Oregon region. So we can actually drop down to a T2 small, which will cost more like, I want to say like $30 or something much more reasonable. We don't need big resources yet. When we do need big resources, if we have a lot of users or if we create some kind of service that does some crazy calculations or thousands of API calls or things like that in parallel, we could beef up our instances pretty easily, and maybe we'll get to that someday. Key pair, I want to select my SSH key pair. So you'll have to create one of these in AWS the first time. If you haven't created one, make sure you create one first, because you need that to get into your instances that this ECS cluster will create. So it's going to install this NAT3 SSH key on every instance in the cluster. So that way we can SSH into our cluster and debug and see what's going on. So now we're on to the networking bit. So we've created a VPC, and our VPC has this address range of anything with 10.0, and then these numbers could be 0 to 25, 0 to 25. So that's the IP range. And this is a CIDR block or cedar block. I don't really know exactly how to pronounce it. If you ever want to take a look at something interesting, go read into how cedar blocks work. For now, I recommend just sticking with this config, and as long, yeah, I recommend sticking with this config. So yeah, so we've got a subnet here. We've got 3 subnets actually. We've got 2 private subnets for our database, which we'll go over in this video, I think, as well. And 1 subnet for our public, right? For our public. Yes, so this is what we are going to be hosting our ECS cluster in, because we need the wide area network to be able to access our subnet here that has this cluster, so that they can hit the API from their browser. Security group. I have the security group, and it's called Launch Wizard 3. It will show you guys what that looks like right now. So we'll click on here. We'll follow this link, rules for this security group in the EC2 console. Because it's important that you guys see this. Security groups was one of the a key concept in creating your networks, your VPCs on AWS. This My Money Manager Web has 3 inbound rules, and I think we might only need 2. This one might be optional, but the idea is that we want to allow HTTP traffic. That's port 80. That's what all the websites on the web are run on, unless they're run on HTTPS, which is 443, and we want to allow that port in from any IP address. All right. So, and this is any IPv4 address. If you notice the format, this is any IPv6 address. Like I said, I'm not sure if the IPv6 address is required or not. I did it anyways just to be safe. SSH2 or SSH on port 22. We need to be able to SSH to that instance from anywhere as well, because we might need to do some kind of maintenance. I told you guys that Amazon ECS basically keeps the Docker containers running for you. That's once you get them started up. If you need to do debugging to get them to work properly, then you probably want SSH. And so I've opened up port 22 for SSH. And you could eventually harden your environment if you wanted to keep it extra secure. You could close off this port later, so that port 22 could not reach your boxes. So that's what the security group looks like. So we're going to choose that one. And see, I added a name tag here, My Money Manager Web. I wish we would have named it instead of Launch Wizard 3, My Money Manager Web. I don't know if we can change that in the future. It doesn't look like it, at least from the UI that Amazon's built us, but whatever. And then these containers need an instance role to act on your behalf. So these roles will allow the containers to do things like spin up more, I think more instances and things like that. If there isn't a role already here, an ECS instance role, I think you can just let it create one for you. Yeah, create new role. I think that would be fine. I don't think you have to think too much about this. So let's go ahead and create our cluster, and this is going to go and spawn an EC2 instance for us. So this is the existing instance that I had running for that cluster I used to test this setup. And if we refresh, we can see here's our new instance, our T2 small instance being built right now. If we take a look at some of the details, we can see it's been put in availability zone US West 2A. It's got our security group that we specified here. It allows port 80 from any IPv6 or IPv4 address, port 22 from any IPv4 address. It uses ECS optimized AMI, which is important, but we don't have to worry about specifying the AMI because ECS will do that for us. Use the correct key pair. Anything else important? Oh, so if we want to actually access our EC2 instance that ECS created for us, we need to create an elastic IP. An elastic IP is an IP address that's available to the world. If we go back actually to our container that's initializing, we can see that we've got this public IP address, and this is an IP address that's only public to other instances in the AWS network, I believe. I'm not really sure of the exact availability of this IP address, but it's not available to you at home, so we need to assign this instance an IP address available to the world. And how you do that is with elastic IPs right here. Let me make sure the screen's all good. Yeah, we're looking good. Virtual private gateways. Is it cut off a bit? No. Sorry, guys. I just wanted to make sure the video is coming in loud and clear. Looks like we are. So, elastic IPs. Elastic IPs are how you expose a worldwide IP address to one of your instances. So, what we need to do is we need to go here to allocate new address, and we are going to click on allocate right here, and this is the new IP address, elastic IP address that's just been created for us. So now what we need to do is go in here and associate our address with that instance that we just created, or is being created right now actually. So we come in here, it's got the name for us already, fortunately, so we can see this is our My Money Manager EC2 Container Service, and we need to attach our elastic IP to it. Select the only private IP, so it's going to route traffic from this elastic IP to our private network interface at this address, and we are good to go. Close. Let's go back to the EC2 instances console. Looks like we're still starting up here. Usually these take a few minutes to start up. So let's go over to VPCs so we can explain really quick how the networking works for all of this. So we have one VPC called MMM, and basically we have this CIDR block I was showing you earlier that says any address that starts with 10.0 can be created on this network. Basically, this is the address range of this VPC, and VPCs have logical kind of subnetworks called subnets. And we need 3 subnets for this project. We need a public subnet that allows users to access our project from the web, and a public subnet has a certain component that allows traffic to be routed to and from the web, and that is called an internet gateway. So make sure when you're creating your public subnet that you assign an internet gateway here as a target for any incoming IPv6 address, possibly any IPv4 address, and possibly any IPv6 address. We don't have that here in this instance. Didn't need it for some reason. So that's our public subnet. We can see we didn't change anything here with the network ACL, and then we have 2 private subnets that are pretty much the same, except they have different CIDR blocks, different address ranges, because they can't overlap. We needed 2 private subnets for our RDS, which is our database, and I'll show you why we needed that in a minute. Yeah. So let's go back to EC2, and if you guys ever want to add tools to your bar up here, you'll notice when you start AWS it's kind of boring and stark. You can go here and click this edit, and you can kind of drag and drop features onto here that you can use, so you don't have to go through the trouble of, and I will show you, normally you would have to click on this box here and go all the way over here to EC2, but we don't want to do that. So yeah, let's take a look at our instance. Our instance running. Let's see if Everything's good, and let's see if we can SSH into that box, and that'll tell us that it's accessible from the World Wide Web. So here's our Elastic IP that we associated with it. And we can go and use our private key from the key pair that we gave Amazon to put on those instances to SSH, and I believe the user is EC2 user, and then at the IP address, looks like we're good because we're in. And we should be able to run Docker PS to list out the processes running. And look, our ECS agent, which is the what would you call it? The application responsible for calling back to Amazon and for receiving commands from Amazon in regards to like scaling and starting your Docker containers and keeping them running. We can see that the Amazon ECS agent is running. So that is all good. So now we need to put a service onto our instance here, or onto our cluster. So let's go to the Amazon EC2 Container Service, and we are going to go into our cluster, and now we're going to create what's called a service on our cluster. So a service is the specification for, well actually sorry, before we create a service we need to create a task definition. Sorry, that was a little confusing. So yeah, skip going to clusters. We're going to go to task definitions, and I've already created this task definition, and you'll find it in the project which can be found at my GitHub, github.com/nader1067. I've got a couple repositories here, My Money Manager front end. I would clone both of them. My Money Manager has the task definition on it, so you can go in here and find ECS task definition, and this has most of what you need for the task definition. We're going to need to work on, I think we've already done the build portion of this, but I'll go back and check in a second. So this task definition describes the Docker containers that need to run next to each other on ECS in order for your application to work. So in our instance, we needed 2 Docker containers. We needed one for Nginx and one for PHP FPM. PHP is a pretty complicated platform to deploy, unfortunately, but Symfony is just so good that we're willing to deal with it, at least for now. So our 2 containers are our PHP container, and we expose port, this is our Nginx container named Nginx, and we read our volumes from the PHP container so that we can share files with PHP. We also expose port 80 so that outside web requests can hit our box and make calls to our API on the container through the ECS cluster in that instance that we created. We specify a Docker image. Let's make sure that we've gone over this already. Building the Docker image, actually. 6261. I guess I'm probably gonna go back and explain how we go over, or how we build these Docker images. It looks like that might have gotten lost in translation. So we'll do that in another video. I'll probably tag this one as 7.1 and add a 7.0 or something like that as far as lessons go. But these are Docker containers hosted in our AWS. And those are actually right here in repositories. So in that lesson we created 2 Docker containers. We created one for Nginx, one for PHP FPM, and we pushed them to this repository store here and then we're able to use them in our ECS cluster very easily. Back to the task definition. Another important thing is that we use this links here. This means that the Nginx container can communicate with the PHP container, and the PHP container is important because it's running PHP FBM, which helps Nginx serve the files. And we see that the PHP container has this image here. This is again a link to the repository here. So I suggest you take a look at this task definition when there's time. It took a lot of tweaking and debugging to get this to work, but it works now. So it's my gift to you. I hope you guys like it. Share it as much as you want. So now we're going to go and actually create the service. So we're going to go back to our cluster, and we're on the services tab here, and we're going to click create. Creating a service is easy once you have the task definition set up. All you have to do is tell it which version of the task definition you want to run, what cluster you want it to run on, our newly created cluster, what you want the service to be called. I think we call this My Money Manager API. Could also call it My Money Manager Web. I think API is good. We only need it running in one place because we don't have a high load, and we know that ECS, if our container does fail, ECS will spawn another container quickly enough that we probably will be able to give still high availability to our customers, users, whatever. And then the rest of these for now are going to be good. Eventually we're going to add elastic load balancing if we have more than one container running. For now we're not going to because it costs like $10 a month or something. We might as well save that $10 a month. So let's go ahead and create the service. So now this is going and deploying our containers. And so it's copying our containers onto the EC2 instance that it created, and then it's going to start them up, and then it's going to link them together so that they can communicate with each other and serve us files. So let's go into our service here, and we can see some logs. So we can see that this task is pending right now for our service. We have one task, and the task has two containers running on it. It's already gotten our PHP FBM container running because it doesn't have any dependencies. And it's working on deploying our Nginx container. Our Nginx container is good to go. So now if we take this same IP address that we SSH'd into, or actually sorry, we're already in here in the server. Why don't we take a look and see that these containers are running? All we need to do is run Docker PS to view the processes, and we can see right here that our Nginx container is running here and our PHP container is running here. They're communicating with each other, and they're both running, which means in theory they both work. So let's go ahead and grab the IP address of that instance, and we should be able to go to that IP address in our browser, type in the health endpoint, and we see status healthy. Cool. So we've just deployed a Symfony application in, what was that? Probably about 20 minutes or less. Cool. That wasn't bad at all. Thanks for watching, guys. I think we'll probably end this segment now so that we have a video describing how to deploy the Symfony application. Then we'll do a separate video of deploying the React application. So thanks for watching. As always, if this was useful to you guys, subscribe below. Give your feedback. I'd really like to know what you guys think about the video. Feel free to share any code with your friends or anyone who might need it. The code's up on GitHub, github.com/nader1067. I'll post the link on the channel. Thanks again, and have a great day.